The strategy used to protect a line is commonly referred to as a scheme. All protection schemes used in distance relaying fit into one of two categories: pilot-aided and non-pilot-aided schemes. The main difference between the two types of schemes is that the distance relays used in pilot-aided schemes communicate with each other to determine whether the fault is located on the transmission line or not. The relays used in non-pilot-aided schemes do not communicate with each other and instead use delays and other forms of coordination to determine whether the fault is located on the transmission line or not. All coordination in these schemes is done within each individual relay itself. In the category of non-pilot-aided distance protection schemes, there are two main types that we will discuss. These are the stepped distance protection scheme and the Zone 1 extension scheme. We will first describe the stepped distance scheme. This scheme is the basic structure for all other distance schemes, so it is important to cover it in great detail. The stepped distance scheme uses 4 different zones of protection to protect its own transmission line, and to act as a backup distance relay to protect transmission lines that are located next to it. We will use the power system shown here to describe how the 4 zones of protection are set and used. The main transmission line we will be protecting will be transmission line number 1, and the relay will be located at the far left of that line. The first zone of protection is set to under reach and extends from the beginning of the transmission line to 80 or 90% of the length of the entire line. This zone is also set to have no time delay. Therefore, if a fault occurs in this zone, the relay can be sure that the fault is located on its transmission line and can trip immediately. Zone number 1 will not protect the last 10 to 20% of the line, which is known as the end zone. Any faults that occur in this area will not be seen by zone number 1 and will have to be cleared by one of the other zones of protection. The second zone of protection is set to overreach and extends from the beginning of the transmission line, past the end of the line, and into the next adjoining transmission line. This is called Zone 2. Zone 2 is usually set to 120% of the impedance of the transmission line. Zone 2 is set in this manner so that it can detect faults that occur in the end zone area that zone number 1 cannot detect. Zone 2 is also always programmed to have a time delay set between 0.25 and 0.4 seconds. Using all of the characteristics we have just discussed, Zone 1 and Zone 2 have the ability of protecting the entire length of the transmission line in the following way. Any faults that occur at the beginning of the transmission line will be picked up by both Zone 1 and Zone 2, as seen by the status of their pickup flags. Since Zone 1 has no intentional time delay, its operate flag will turn on immediately. The Zone 2 operate flag will not yet turn on because it has a time delay programmed within it. The Zone 1 operate flag will then trigger the relay to trip to clear the fault. At that point, the fault will be cleared. The Zone 1 pickup and operate flags will turn off. The Zone 2 pickup flag will turn off, and the Zone 2 operate flag will stay in the off state, with never having turned on. On another occasion, if a fault occurred in the end zone region of the transmission line, the two zones would act differently. The fault does not lie within the zone of protection of zone number 1. Therefore, Zone 1 will not pick up. The fault does lie within the zone of protection of zone number 2. Therefore, Zone 2 will pick up. After the Zone 2 time delay has expired, the Zone 2 operate flag will change to the on state and trigger the relay to trip and clear the fault. Once the fault is cleared, both the pickup and operate flags of Zone 2 will turn off. You may be wondering what would happen if a fault occurred on the adjacent transmission line, but still within the Zone 2 area of protection. Normally, after the Zone 2 time delay expired, the relay would trip the unfaulted transmission line. However, you have to remember that every adjacent transmission line is protected by its own distance relay. This fault would fall into the second relay's first zone of protection, and the fault would be cleared before the timer of Zone 2 in the first relay expired. The third zone of protection is set to overreach past the end of the second adjacent transmission line. The third zone is used to act as a backup for that next adjacent transmission line in case the protection on that transmission line fails. For this reason, Zone 3 is usually set to extend to the same point as Zone number 2 of the adjacent transmission line, so a setting of 220% of the impedance of its own transmission line is often selected if Line 1 and Line 2's impedances are the same. Zone 3 must have a time delay that is longer than the operate time of Zone number 2 of the adjacent transmission line. A time delay of 1 second is commonly used. Zone 4 is used as backup protection for a small portion of the adjacent transmission line in the reverse direction. The operation of this zone is usually time delayed to allow the first zone and second zone of that adjacent transmission line to operate first. A time delay of 750 milliseconds to 1 second is common. Once each of the 4 zones have been set, the step distance scheme to control the breaker on the left side of the transmission line is complete. However, the breaker on both ends of the transmission line must be opened to completely clear a fault. Therefore, another distance relay must be located on the right end of the transmission line to control that breaker. The relay on the right needs to be programmed with the same characteristics as the relay on the left. However, this one will be set up to be protecting in the opposite direction. Now, the zones of protection of each relay will detect any faults that occur on our protected transmission line. These relays will then proceed to open the breaker and clear the fault from their own respective end of the line. Each relay will also have ground step distance zones of protection, which are identical to that of the phase step distance zones. The difference being that the ground distance elements are used to detect single phase to ground faults.